Hi, this is Sarah Parker, and I am doing assignment 4 for machine learning. This is a pretty straightforward assignment. This was character level with a recurrent neural network text generator. So the basic premise of this is that we uploaded an entire text, and I chose Pride and Prejudice by Jane Austen. And then with a recurrent neural network, we used a 3-layer long short-term memory network. And so essentially this type of network is different than a CNN because it actually uses the preceding characters to predict the next character. So it kind of has like a memory slot associated with it. So it takes our from our input from the previous one and helps that to train the output for the new features. So essentially we trained this for 50 epochs. It took about 45 minutes to run the code on a Google Colabs with a T4 GPU. And the idea was that we generated 20 character sequences, and those should resemble the English prose associated with Pride and Prejudice. So not just random words, but words in sentences and phrases that would be similar to the style of Pride and Prejudice. So I did do a random seed so that all of the code is reproducible and the results are the same. I will go over to the code real quick. Just to kind of do a brief rundown. So you can see we downloaded the code or downloaded the text, I apologize, and then we cleaned it. So we wanted to make sure that we just had words and then spaces in between those words, and then just collapsing all those extra spaces. So this was our final data. It had 728,000 characters, and it was by Pride and Prejudice. That's the author, Jane Austen. And then this is how we define our model. We have an LSTM model. We use the Atom Optimizer because of its ability to learn. And then we used a dropout for this as well. We ran it for 50 epochs. Oh, started again real quick. While it's starting, you can see that initially it's showing words, but it's not necessarily, it's kind of nonsensical words. While that's running, I will let up in Word. This was my final report. So you can see that we use one hot vector encoding with our LSTM, and then our output, we retained our logits. And then we did 3 layers and applied a dropout to reduce overfitting. So this kind of captures that like short-term and long-term character range to give us more of an output consistent with Pride and Prejudice. These were the hyperparameters that were chosen. And then essentially our results were really good. So our model was trained for 50 epochs, and our loss decreased from 2.1 down to 0.5. So that's a 73% reduction, which is great. That's exactly what you're looking for. You want to see that steep initial drop, and then you want to see kind of that stabilization. And there was no flattening or dips to indicate anything else. So this is what was generated. Our first sequence was Bear the Distress of. And you can see that it actually included the ending of the book and kind of the headers. And so that's why you get these kind of weird, they look like anomalies, but it actually just learned the whole book, and that included kind of that classifier information. But as you get further along in our epochs, you can actually see we're getting closer to real sentences that are similar. Mr. Bennet was that she is a very fine. He had been probably traveling, had that been able to continue longer. And so you get much more distinct sentences or phrases that are consistent with Pride and Prejudice. So epochs 1 through 8 was mostly noise, but 9 through 25 definitely showed those character names and the prose associated with it. And then by 26 to 50, that's where you get continual improvement and then kind of more of that natural dialogue. The contamination, that's really just talking about how it gathered information from the appendix or the chapter headings rather than from the actual text in the chapters. And so something that would be easy to do would be to kind of strip those headers and the license from the raw text before, and that would kind of eliminate this contamination, and it would probably learn even faster. So there really weren't too many difficulties associated with this. We did all of this in Google Colab because I struggled to actually get it to run locally, but it runs perfectly in Colab. And then it worked exactly the way we wanted it to. So we got a really good training model that decreased the loss pretty significantly, and the output was exactly what we were looking for. So that was assignment 4. That was our relational neural network to generate text similar to an input. Thank you.